Okay, in this section of the video, this is part 3, we're going to go over the color changing system for each hexagon. And then at the end of the video, I'm going to show a preview of the square version and triangular version of this system, which works basically the same. The equation is slightly different for calculating adjacencies, but other than that, it's the same system. So here's what we had before, and I'm just making them a bit shorter when you spawn them in, and then also scaling them up a bit once they've spawned so there's no more gaps, so you get a nice cohesive area of where you've spawned in the tiles. There we go. Next up, we're just making the highlighted color a bit more distinct, and we're going to plug the color in our material into the emissive as well as the diffused color, just so it looks a bit brighter and pops out a bit better. Okay, the next section we're going to make is we're going to make a function. We're going to call it Shift Hue, and what this function does is it reads in an integer or a float in our case, and then it turns it into hue. It's probably the most complicated part of this video, but I have the blueprint you're going to need on the screen, both the left and bottom right here. To be honest, I'm not even quite sure how it works myself. I can roughly explain it, but mostly I looked up like how do you get a color variation out of a single float, and this is what came up. It's not the full color wheel, like you don't get different saturations or different luminosities of colors. All the colors you're going to get is just going to be the same color but a different hue. So it is somewhat limited in that way, but it gives what we need in this use case, which is as you scroll your mouse, when you're trying to select between colors, it will shift between different types of colors, all at the same saturation, but it gives us the variation we want. In terms of how the function outputs, we're just putting a bunch of return nodes at the end of these branches, and then we're making a make linear color node, and then we're bringing in the hue segment fraction, which gets created with the first part of the function. And broadly speaking, you can kind of see how it works if you just kind of walk your way through the blueprints. I don't know if this is the standard way of shifting hues, but it certainly is effective. And you're kind of cycling between different sections of the color. The first part, it has to be an integer and the second part has to be a float, because the first part is just the broad color, kind of what main section is it. Is it red? Is it green? Is it blue? And then the second one, the color 2, which is a float, the fraction, that will actually slowly get adjusted within that kind of section. So that way you can have a smooth transition between different colors. Okay, so now that we have that function made, now it's time to implement. We are activating the hover event. We're going to need 2 events in the camera section, and then we're also going to add those at the end of the cell here. We will need to cast to the camera BP. I'm going to do a pure cast because we know for sure we're going to get the camera BP. It doesn't have to be a pure cast though. So here's the start hover event and end hover event, and the main thing we're doing here is we're just getting a reference to the cell, and we are going to set the hovering boolean, and then we are going to turn off the hovering boolean and then clear the reference to the cell when the hover event ends. And of course we're going to set that up in the actual cell. Same thing for that end hover event, but we don't need a reference since we're clearing it. Gives us a warning here since we didn't compile, but if we compile, it will work. Now that we have those events set up, we're going to, if you remember from a previous video, this is the section we made for zooming in and out. So we're going to use the same zooming in and out, or the scroll wheel anyway, to change the color. So what we're going to have it do is when you're hovering over a tile or a cell, it will change the color, versus when your mouse is not over a cell, it will zoom in and out. In the game we're drawing inspiration from, they don't have it change color, they actually have you rotate the cell. Because it's a game that has like forest and roads and towns, and the rotation of each cell kind of matters. It's part of the gameplay. But in this prototype, I wanted to do something that approximates that, but I didn't want to set up a whole road system and interconnected system. So I just set up the color change. But if you did want like special adjacency rules for roads and forests and things, you could kind of hook it in with the same hover events to validate if you're over a cell. But of course, instead of changing the hue, you would want to rotate the actual cell. You notice in the examples at the bottom of the screen, there might be a few differences here and there. So for example, I update the color at the end of right after set cell color, and that's for a specific reason later. And then we're going to update the cells here. This one as well, there's a few bugs we fixed later in the video, but the example on the bottom right has the completed blueprint. I think I experiment with increasing the value of the color so it's a bit brighter when you hover, but I don't actually like that. And I would just make it the actual color. It gave us an error there, but that's just, once again, we didn't compile. make sure to put a default value into the hue. Here we're kind of debugging, it's black, and it's like, okay, what's going on here? And it's also activating just when we hover over things, which we don't actually want it to do. We want it to reset to the original color. So I noticed I plugged this into the wrong spot. There we go. And the cell color, we needed to set that to something default as well. And set the hue to something by default. So we have, right away, we have the hue feed into what the color should be. You notice there is a weird overlap happening there. That's what we will fix next. That actually is caused by a spawner issue. Spawners are, by default, they try to be smart, where they'll move things around a little bit if they're in the wrong spot. So if you check the spawners here, under the collision handling override, you actually need to change this. To always spawn, ignore collisions. And you notice now that we did that, nothing gets shifted around. And everything, regardless of how big you make it, everything is on a perfect grid. Here, I don't like that color, so just removing it, just so I can preview our colors a bit better. So if it looks red, it spawns in as red instead of a different shade of red. In terms of the scrolling, you can change how aggressively it changes colors. I think I did mine with like +10 or something like that. And here I'm moving around the update color because it didn't actually start at the hue you wanted, which means if you placed the color and then you shifted it, it was really hard to get back to that color because the original hue was just some random color, and it wasn't even clear that that color was possible to get back to. I'm just brightening up the colors by multiplying them by a float, just so it's a bit more vibrant. And there you go. Nice hexagon placing system. Here we're fixing a bug, or not really bug, but I want to be able to change the color of already placed cells, but I don't want it to redo everything if the cell is already placed. So I'm just adding in a branch to where, like, hey, if it's not placed, then go ahead and activate the cell placed and change the scale. If it is placed though, just change the color. Don't actually do anything else. So you notice if you place a cell and then change the color and then click on that cell again, it'll go back. Here's the square one. The square is much easier to calculate adjacency. You literally just use the box extent plus the offset and make a vector. And you only need 4 sides instead of 6. And then here's the triangular one. A little more complicated than the square because you have to account for a rotation. You can't just do adjacency alone, since obviously the triangles have a direction. But it's not too bad if you know how to do the hexagon. Just a little bit of math and you can figure out where to check for the triangles and where to place the little grids on them. Anyway, hope you all enjoyed this series. I thought it was interesting. I really liked the game. It was inspired by, it's a very chill game. Feel free to check it out, and hope you learned something. Y'all have fun.